Hi dear student, welcome to everybody to our online classes on behalf of Chorashwati Bandha Degree College. This is Sujal Chandra Burman, lecturer chemistry, Chorashwati Bandha Degree College. Dear student, in our previous classes we have discussed about the preparation of benzene and electrophilic substitution of benzene, and we have seen the reaction mechanism of nitration. Today I will discuss on sublimation and other electrophilic substitution of benzene like as fidelity calculation, acylation and chlorination. So dear student, let us see the reaction of sublimation. In this reaction, benzene will react with concentrated sulfuric acid at 100 degrees Celsius and to produce benzene sulfonic acid. The benzene sulfonic acid, this is the product of this reaction. So dear student, we have to know the mechanism of this reaction. So see the mechanism of this reaction. Dear student, in our previous classes in nitration reaction we have seen that this electrophilic substitution occurs in 3 steps. The first step was the preparation of electrophile. The second step was preparation of sigma complex, and the last step was elimination of proton. In this way we will see the mechanism of this reaction. So in first step, here sulfuric acid is the reagent of this reaction. Here 2 mole of sulfuric acid react to each other and will produce electrophile and others. Here see 2 moles of sulfuric acid react to each other, produce hydronium and sulfur trioxide and bisulfur ion. Dear student, in our previous classes we have known it that the electrophile was the positive one. So we have to name that here hydronium ion is the electrophile, will react as electrophile, but here sulfur trioxide will react as electrophile because of resonance structure of sulfur trioxide. By the resonance structure, in sulfur atom always produce a positive charge and it reacts as a electrophile. So let us see the resonance structure of sulfur trioxide. In this case, we can see it, we can show it in this way. Here the valence of sulfur is 6 and the valence of oxygen is 2. Here oxygen is more electronegative than sulfur. For this, oxygen attract the pi bond to itself and create a negative charge by this way. In second step, it creates an anion on sulfur atom and a positive charge produced on sulfur atom. And second step, we can show that here also other atom of oxygen will also attract the pi bond to itself, and this negative ion come here and create a pi bond. So you can see this negative charge on oxygen and here this, and in this structure, in resonance structure, also a positive charge on sulfur. In other structure we can also show that the oxygen atom attract other pi bond to itself and create negative ion, and we can write down it by this. So dear student, see the structure of sulfur trioxide. Here positive charge and positive charge. For this, sulfur trioxide is a strong electrophile than hydronium ion. As a result, in this reaction, sulfur trioxide reacts as electrophile. So dear student, we can say that as a result of resonance structure of sulfur trioxide, it creates a positive charge on sulfur atom and reacts as electrophile. In second step, this electrophile attract to benzene. It attract to pi electrons of benzene and produce a sigma complex by this way. See the structure. Here, sulfur trioxide has a positive charge on sulfur atom. It attracts the pi bond of benzene. For this, produce a sigma complex. Here, this is sigma complex. In sigma complex, it lost its aromaticity. To recover its aromaticity, we need to create a pi bond in benzene. For this, we eliminate a proton from this sigma complex. In last step, we can show that from this sigma complex, a proton will eliminate by a base, which is bisulfite ion. Here, bisulfite ion react as base which will attract a proton from it and create sulfuric acid and this anionic compound. Here, benzene has gained its aromaticity, but there is a negative charge on sulfur trioxide, and it's not benzene sulfonic acid. In last step, this attack hydrogen ion from hydronium ion and will create benzene sulfonic acid, and which is the final product and water. So dear student, this is the mechanism of sulfonation reaction. Next, we will discuss the other electrophilic substitution of benzene. So dear student, see the reaction which is known as Friedel-Crafts alkylation reaction. First, we see the reaction. Here, this is benzene, this is alkyl halide, and this is reagent which is anhydrous aluminum chloride. So dear student, we can say that if benzene reacts with alkyl halide in the presence of anhydrous aluminum chloride, which is known as Lewis acid, then it will produce alkyl benzene and hydrogen halide. So dear student, we can if we take here alkyl halide as methyl halide or methyl chloride, then the reaction will be here. This is benzene, and if we take methyl chloride as alkyl halide, it reacts in presence of anhydrous aluminum chloride, then it will produce methyl benzene, which is known as toluene and hydrogen chloride. This is the product of this reaction. This is alkylation, because of here alkyl radical has come to the benzene, which replaces the hydrogen atom from benzene and produce alkyl benzene. For this, it's known as alkylation reaction. So dear student, let us see the mechanism of this reaction. So the mechanism of alkylation is we can show this mechanism of this reaction. Here, methyl chloride and aluminum chloride is the which is reactant, and this is reagent. This reactant and reagent react to each other and produce, in first step, it produce electrophile. See the first step. In first step, methyl chloride Cl react with aluminum chloride. Just I have said that aluminum chloride is the Lewis acid, which is an electron deficiency compound. Here, in methyl chloride, there is lone pair electron. As aluminum chloride is an electron deficiency compound, is attract the lone pair electron to itself, and for this result, this bond will break down and will produce electrophile, which is known as methyl carbonium ion, and an anion which is known as aluminum tetrachloride ion. Here methyl carbonium ion is a electrophile. In second step, we can show that we can show that this electrophile will react with benzene and will produce a sigma complex. Here a pi bond, this electrophile will react this pi bond, attract this pi bond and create a sigma bond with benzene and will create a sigma complex. This is the sigma complex. In this compound, benzene has lost its aromaticity. To recover its aromaticity, we need to remove a hydrogen atom from this compound, which will remove as hydrogen ion, and this electron will come to benzene ring, and this benzene ring will get its aromaticity. For this, we can see in third step here the sigma complex will react with aluminum tetrachloride, which will react as a base, will attract hydrogen ion. This will remove or eliminate as a proton, and this bond will come to benzene ring and will create a pi bond in benzene ring. Then we shall get this, which is known as toluene, and will produce aluminum chloride and AC. So dear student, this is the final product, which is known as toluene. So dear student, this is the mechanism of alkylation. So dear student, I hope you have understood the two mechanism of the electrophilic sulfonation of benzene. The one is sulfonation and the other is alkylation reaction. So dear student, we have rest of electrophilic substitution reaction like as Friedel-Crafts alkylation. Dear student, in Friedel-Crafts alkylation reactions, the mechanism of this reaction is the same as alkylation. So this is the Friedel-Crafts acylation reaction. Here acyl radical will add it with benzene ring. So it is known as acylation reaction. This is your homework. I hope you will try to yourself to your home to write down this mechanism, and we have to think this question that here we use anhydrous aluminum chloride. This is the question for you, that in Friedel-Crafts alkylation and acylation reactions we use aluminum chloride. Why? Dear student, please try to give this answer yourself. And the last is fluorination reaction, which is this reaction in benzene has fluorine in presence of iron chloride, which is known as halogen carrier, and in presence of this halogen carrier, fluorine will react to benzene and produce chlorobenzene. So dear student, this mechanism is also homework for you. So dear student, today's class, I hope you have understood the mechanism of these two reactions, and you have to do the rest of the reactions and mechanism. So thanks to all the students. Please try to solve this problem to yourself. If you face problem, then you may communicate with me. Thanks to all. Best of luck, dear students.